Hi again. Well, I hope you enjoyed that video on the t-distribution and the history of that. I find that so interesting, and I mean, of course I would, right? But I hope you did too. So now I want to show you, I want to play around with a t-distribution on Staplet and show you what it looks like. So I'm going to go over to Staplet, and you probably have a direct link to this, but under probability, if you're at staplet.com, sometimes it's easier just to go to staplet.com. There's a t-distribution. Okay, it starts out just like the normal with two options: calculate an area or calculate a value. Okay, and then there's only one input, which are the degrees of freedom. So I'm just going to start with 1 and plot it and just see what happens. Wow, look at that. Isn't that interesting? So there's much more area. The tails are much fatter, right? We can check this box to also see the normal distribution. But you know that the normal doesn't go out to 6. So it usually only goes to about 3. So the tails, the smaller the sample size, you have more room for variation, right? You have more more in the tails. You might just play around with, there's a little arrow here, you can just go up and see how the more degrees of freedom, so the more data you have, the closer and closer it gets to a normal distribution. And you might guess that we should probably get up to 30 to be pretty close, since that's the condition is the sample size if we have 30 or more. Even though we're still using the t-distribution, but okay, so yeah, maybe it has to get higher than, I'll have to think about that. Maybe it has to get higher to use, even higher to be a normal distribution, but we need 30 to ensure that we can use the t-distribution. Okay, so let's look at, in our particular case, we have 15. Remember back to the student credit hours, there were 15. So if I put in 14 and see what that is, okay. Now we would use an area for a p-value, right? So we're not doing hypothesis testing yet, but we will. So we'll come back to this area, but just so you kind of get a sense, it has the same exact options between left, right, or outside. We are actually going to do a value, because that's what a critical the t-star value is. Critical t-value is a value. Okay, so let me go back to the notes for a second here. So on this, just to show you back on the area part, finding an area, and let's just make a note as n gets large, or as the degrees of freedom get large, the t distribution gets closer and closer to the normal. Distribution. Okay, you can look up if you're interested how high it has to get. Okay, so now what we are going to do next is what we need for confidence intervals is this critical t-star value. Okay, now you might remember with proportions we had 4 main ones, because we had 90%, 95, 99, and 80, I think. This is not the case for t-stars, because we have to find this for each sample size and confidence level. Because the input is the degrees of freedom, there's no way we can make a list for every single degrees of freedom and every single confidence interval. Or sorry, confidence level. So we're gonna get a lot of practice finding these critical t-stars. Okay, you've done it once with proportions, or maybe even more than once. So let's go ahead and go through the steps for that. Okay, so for that we're gonna need to calculate a value. I'm just gonna circle the area on the previous one. I forgot to do that. Okay, and we have 14, so let me show you how to do this, and then we'll go back to the screenshot. Okay, so I've got the top operation set to calculate a value. I put in my degrees of freedom. We don't really need this normal plot anymore. Then we always want to do central, right? Calculate boundary values for a central area. because we're determining how many standard errors do we need to go out to get a certain central area, right? So if we want to do, we did 90%, right, when we were bootstrapping, so let's keep that consistent. A 90% confidence interval, so I put in 0.9, calculate values, and this tells me I need to go out 1.7613 standard errors, because we're in a sampling distribution here. Let me check, show labels. If this middle area is 90%, and if we go out 1.7613, okay? I forget what the number is for normal. I know when it's 95, let's just compare. When it's 95, oops, when it's 95, I know it's 1.96. So it makes sense we'd have to go out a little further for the T, at least for the 14 degrees of freedom, because see how this goes out to 4 instead of 3? So anyway, just comparing a little bit with the normal curve and the process you are already familiar with. Okay, so in our formula, our T star is going to be 1.7613. And it's the negative and the positive, but that's taken care of in the plus or minus in the formula. Okay, so let's go back and we should see this value on our notes. Here we have degrees of freedom is 14, and remember that is 15 minus 1 is 14. And so, and they put a little T14 there, and we did a central area of 90, it was 1.7613, so got the same thing. And that would be our T star 14, right? I just put the 14 there for reference, because if we did a T star, if we had 20 data values or 7 data values, that would change, right? So our T star 14 is 1.7613. Okay, now as you're doing this, you might need to change your Staplet to 4 decimal places to get this exactly, okay? So let me just make a note of that. Change settings to 4. We probably already, you likely already have that, but just in case. Just a reminder, you do that in the link at the bottom of Staplet, and you can also change percentage or decimal. I like decimal. Keep up to 4 digits of precision, round to as many as 4. If it's not doing it, you might have to do always round to 4, so play around with it. Okay, great. So that is the T distribution, and let's go ahead and continue on the next page. Just gotta get my other window here, back to my notes. Okay, so we're gonna continue with the situation we're in with the credit hour data. And we're gonna check the conditions needed to use the central limit theorem, okay? So remember, if we're gonna use this formula, we have to make sure the conditions are met. So I've got my conditions right here, if I need to refer to that. Okay, first one is independence. Okay, so the Math 244 students, math or stat. Now this was a fake random sample, and I'll show you why when we look at the graph. But those samples need to be independent in the number of credits they're taking, right? That's the variable we're measuring. Must be independent in the number of credits they are taking. Okay, so we need to think about what are some things to consider. Whoops. Got ahead of my writing. Consider when we are taking a random sample, right? Let's say we really want to do a random sample. What are some things that might affect credit hours? maybe how much someone's working, maybe if financial aid has certain requirements of number of credits you have to take to get certain levels of financial aid. Just think of all different things that might affect the number of credits students are taking. So I'll put a couple: financial aid status. So which also might have to do with income. What was the other one I said? Can't remember. I feel like there was another one I mentioned. I'll have to rewind it. Financial aid status, income, maybe just, freshman, sophomore, junior. I don't know. Oh, working. How much? Amount working, etc. Okay, so we want to consider all those things when we're taking our random sample. The next one is randomization. Okay, so we need a random sample. Of students. Okay, so when we do our class survey, this is not going to be a random sample, right? It's a convenience sample, so I'm just going to make a note of that. So our class is not a random sample, but we are going to do this with our class data because it just helps make it more concrete when you're connected to the data. Okay, next one is large population. Okay, so we can think of doing this as the fictitious data set or our class data set. Either way, the population must be 10 times the sample size, right? So the population of PCC students, or actually, sorry, we actually want stat 243, 244. Let me just write 244 students, stat, or math or stat 244 students must be at least 10 times the sample size. Okay, so in our example, we had 15 times 10 is 150. Depending on what our class size is, it needs to be 10 times that when we do it for our class. Okay, and now sample size, that's the new one. Sample size, if we look at our fake data, the sample size is 15 for the fictional sample. So we don't have 30, so the sample must be nearly normal. Okay, so we need to check this. We can't just look at a list or just say it's nearly normal. We need to check the histogram. Okay, so I'm going to write how to check. Make a histogram. Okay, so how do we do that? There's many ways to do that. We're going to use Staplet in case you haven't used it before. It's a really good tool and it has simulations in it as well. So I'm going to go over, first of all, I'm going to copy this data again, even though it might be still in my clipboard. So copy the data from the Google Sheet or from the Word doc of the notes. And now, let's see, I do have a Staplet. I'm sure you have a direct link for this right above the video. Staplet.com, or you can go to Staplet.com. We want one quantitative variable single group. We're doing a single mean here. And then, oh, that's right. This one has the variable name separate. So I'm going to copy the variable name and paste it in to there. I'm going to select raw data, and then I'm going to do, I could have done it out of order if I wanted to. I'm going to copy the data again and put it into the second input, or actually the third input, which is the actual data. Okay, we have raw data. We can just do this with the mean and standard deviation. We wouldn't be able to check nearly normal, of course, but we could do some things in that case, so I'll show you later on. Okay, keep it with raw data. Click on Begin Analysis, and the dot plot is the standard, the default option. We want histogram. Okay. Okay, so this is why we're doing a fake data set, so that I could make it nearly normal, because it does not, may or may not be. So we'll see how it comes out for our class. Okay. So this is great. If you want to show box plot, you can see both of them. It helps with symmetry. Right above that, that's our stacked histogram and box plot. Also love that it labels it, whatever label we typed in, and we always want to have the units there, of course. Then down below, it gives us the summary statistics. So we see that mean. Remember, we found that mean of 14.2 credits. Also have a standard deviation of the sample and our 5-number summary. Okay, so all that's really useful. So this does appear nearly normal to me. It's roughly symmetric and unimodal. There's no outliers. That's the other reason to have the box plot, is it'll show outliers. And I wouldn't say there's a strong skew. Okay, you can also check the mean and the median, 14.2 to 5. So the mean is slightly less, so there's maybe a slight skew to the left, but I wouldn't call it a strong skew. You can see the center, the left side maybe looks slightly longer than the right side, right? Okay, so I would say that this is nearly normal. And you can see there's some inference options down below that we'll get to. Okay, so I've got, by the magic of technology, I have a screenshot of that. Okay, so we are using, so essentially we're going back and we're reviewing some descriptive statistics, right, that we haven't used since 243. So one quantitative single group is on Staplet there. We want to do a stacked histogram and box plot and calculate the summary statistics. Okay, so here's what we did. We entered in our variable name, and then we inputted the data, then begin analysis. So we just want to paste both of these as much as possible, especially the data, because you don't want to have a typo that changes your answer. And you can copy these also right over from MyOpenMath when you're doing your homework, okay? Okay, and then graph type histogram. Everything else is pretty much just default. Also show box plot, okay? You can play around with the bin width or interval width of each bin if you want to, which does sometimes kind of change the shape, but so if you feel like you want to play around with that, you're welcome to. Okay, so what is the shape of the data that we're looking at? So I would say the data are unimodal, one peak, and roughly symmetric. Okay, so we can say nearly normal. Because it's not too skewed and there are no outliers. Okay, so now you know why I did the fake data set, just to make sure that we were going to be able to continue with this. Okay, I'm going to go to the next page because I already mentioned this. next part. And here, so that was the input screenshot. Here's the output that we got. Just might be a refresher. How can you use the mean and median to decide or confirm the shape? Okay, so remember, if the mean and median are close, then you can say it's pretty symmetric. If the mean, all right, approximately equals, the mean is approximately equal to the median, it's symmetric. And if the mean, in this case, the mean was less, but, you know, barely. So you want to think, so that would be a more approximately equal. If it's significantly less, then that would be skewed left. And if the mean is greater than the median, it's skewed right. Okay, so we want to have this box plot. I'll just say check outliers. Remember, it'll come up with like a star if there's an outlier. We always want to label and have our units. And then down here, so we can compare our mean and our median. Right there. And we also are going to use this. This is our sample standard deviation, right? So that's S in our formula. Okay, great. So I will have you check our class sample. If it's an in-person class, we'll do that in class. If it's an online class, I'll have you go ahead and check that. Check out our practice this, what we just did in Staplet for our class data and see what you think, if it comes up nearly normal. And that'll be different every term, so I'll probably write an announcement what I think. Okay. Alrighty, so then I think I'm going to go on. This one's getting kind of long, so I'm going to do the formula in the next video. We'll actually do the formula for the confidence interval. Now that we've checked all our conditions, we'll go ahead and do the formula. So I'll see you in the next video.